Okay, on this one you're going to be adding, because I got this big addition sign right here. Okay, but you can only add radicals if they are like radicals. It's no different than adding like terms. Like if you had a 5x plus a 7x, that would be 12x. So if you had the 5 times the square root of a 3x plus 7 times the square root of a 3x, you'd have 12 times the square root of a 3x. The radical has to be identical. Right now, my two radicals are not the same. This one is the cubed root of 900, and this is the cubed root of 576. So what I have are 5 cube roots of 9,000 and 7 cube roots of 576. That would be like having 5x plus 7y. They're not like terms. You can't add them. But can I simplify them into like radicals? That is the question. So let's see. I erased my list of perfect cubes. Sorry about that. But I do remember 1,000. 9,000, this would be the cubed root of 1,000 times the cubed root of 9. And then this 5, he's just hanging around out there. And so he's still there. That's 5 times, when I take the cubed root of 1,000, the cube root of 1,000 is a 10. And then this guy here, I can't take the cube root of 9, so I have to leave him as the cube root of 9. But the 5 times the 10 makes this 50 times the cube root of a 9. Plus, and here's my plus sign, right? I still have this plus sign in between. Now I'm going to come over to this one, and the 7 is still there. Now, 576. Sometimes this is difficult, but I would start and I'd ask myself, what's the smallest perfect cube? The smallest perfect cube is 8. Does 8 divide into 576? And I'm like going, 8 goes into 576. This is me without my calculator. 8 times 8, 8 times 7, that's 56. And 8 goes into, oh yeah, it does, 72. So 8 goes into 8 goes into 576 72 times. But 8 also goes into 72 9 times. And even though 8 is a perfect cube, it's a perfect cube with that 8 also. What's 8 times 8? 8 times 8 is 64. So 64 times 9 is also 576. And 64 is a perfect cubed. I don't know if you're following me or not, but I can break it down to be the cubed root of a 64 times the cubed root of a 9. And then, of course, this 7 is still there. I can take the cube root of 64. That is 4. Unfortunately, I cannot take the cube root of 9, so that stays as the cube root of 9. But my 7 times my 4 is a 28 times the cube root of 9. And so now I have like radicals. I have 50 cube roots of 9 plus 28 cube roots of 9. And when you add the 50 and the 28, you just add those like they're coefficients, which they are. That becomes 78 times the cube root of 9. That is my answer. And when you come over to Mobius, they're now allowing me to use the, they call it the equation editor right here. It's this thing. And, oh, I didn't mean to do that. Or did I? Oh, I kicked it out of it. Sorry. Okay, put it back. Put it back, April. There we go. I'm going to click on, let's see, I have to type in, so click on the box, type 78, then click this little A to the B power, and it brings up a menu. We want a cubed root, so click on the nth root right here, and tell it what n you want. You have to delete that n and type in the 3, and then you have to scroll with your arrow buttons on your computer, scroll to the A and delete that and type in the 9. And that should work. And how did I do? Yay! There you go. So now when I did the 8 and the 8, like, you might not see that 64. You might see the 8 first. So it's possible to simplify it this way also. Here, I'm just going to erase all this stuff so I have room on that part. If you were just asked to simplify that right there, just simplify the cube root of 576. And I would start with 8. And I'm like, okay, 8 goes in there 72 times. So you'd start by saying, this is the cube root of 8 times the cube root of 72. And the cube root of 8 is a 2. But if you went to type in the 2 times the cube root of 72, you know, Mobius is going to tell you that it's wrong because it's not simplified all the way. I can break this one down to another cube root of 8 times 8 times 9 is 72. And then this 2 is still there. And so now it's going to be this 2 times, this is another 2 times the cube root of 9. So that makes it 4 cube roots of 9, 2 times 2. If you were just simplifying that. I got the same answer as I did before when I was simplifying it. I just broke it down to be 64 times 9 because I saw it. But if you don't see it, you can break it down. You can break it down again. You could break it down a third time if you need to. You could just keep breaking it down until you found every single perfect cube that was within that number. Anyway, that's it.